Hi, this is a Safeguard compass. It is a wearable voltage and current indicator. It's designed to be worn by anyone who might be exposed to the hazards of electrical energy. People like telecommunication workers, electrical workers, firefighters and police officers, members of the military, construction workers, equipment operators, pipeline workers can benefit from having a hands-free, wearable voltage and current detection technology, a device that will alert them if there is a dangerous voltage or current present that they may not be aware of. When the compass unit is on, it will provide visual indications for both voltage and current. As it indicates with blue lights, it's depicting current flow, and when it depicts with orange lights and directionality, it's indicating voltage. And with a lightning fast push, my unit will both speak to me and show to me the hazard. And if I need to temporarily mute that audible alarm, one quick push, and I'm getting my appropriate notifications. So for more information, watch more of our videos, and thank you for staying Safeguard safe. The compass gives us a very powerful insight into electrical hazards that are within our work environment. And in order to do that, it draws energy out of an onboard battery. That means, of course, over time, it will consume some of that energy and it needs to be recharged. Now, most users report getting an extended period of time before they have to recharge their Safeguard compass unit. And our Safeguard compass unit will also notify you when it's time to recharge. A compass that begins to blink with a pair of red LED lights at each one of the corners is a compass unit that is indicating it's got 15% battery life or less. And when you see those indications, or you need to completely recharge a dead compass, you can do so by taking a USB micro cord included in our packaging and remove this sweat cap that's at the rear portion of the compass unit. When you plug that cord into the rear portion of the compass unit, you can plug it in to any standard USB port. When you plug it in, you can tell that your compass unit is getting fortified with new current because this LED indicator in here will illuminate. This center light illuminates, indicating that your compass unit is actively charging. And in order to make it very easy and very flexible to charge your Safeguard compass unit, we have made this work with virtually every single USB outlet that's out there. At the end of the workday, if you want to shut off your Safeguard compass unit, it's very straightforward and easy. By pressing this center button down, it will scroll through a series of illuminations, and when it gets to those green lights, those little lights will swing to that center LED, indicating that my compass unit has gone to sleep. And in the morning, when it's time to re-engage my compass unit, or in the evening, or in the middle of the night, when it's time to become more aware of electrical hazards in your working environment, it's super easy to turn the compass unit back on. By pressing this button, I get that strobing LED indication that goes out to the end, telling me my compass unit is on. And my compass unit is continuously active and continuously monitoring. And when my compass unit is on, I can tell that because I get this subtle blinking LED indication right there in the middle. Voltage indicators of various types are very, very important tools for keeping people safe from electrical hazards. And when it comes to utilizing those devices, we always want to check the device to make sure that the device is operating, to make sure that it's capable of discerning those hazards. A great way to do that is a process known in many international safety standards as live, dead, live testing. If I wanted to do live, dead, live testing with this particular compass here, I would find some known live source, like a low voltage outlet or some corded device that would be producing an electrical field. And when I hold my compass in near proximity to that energized circuit, I get a validation that my compass unit is on and working. Now, in the possibility that we could be working in a location where there's not a known live voltage source nearby, another way to validate that the compass unit is capable of detecting an electric field is to make one on your body. If I've got my compass unit charged up and I start to rub it vigorously back and forth against my garment, that creates a static or a DC voltage that is changing in strength and magnitude, and that allows me to validate that my compass unit is actively detecting electrical fields. And then at the end of the day, or the end of the work shift, or the end of my use with a safeguard compass, before I put it to bed for the night or for the day, I can do so again by checking my compass unit, by rubbing it and creating an artificial electrical field, or by holding it up to some known live voltage source. Testing the unit to validate the unit is working properly is true for a safeguard compass or any other kinds of voltage detection out there. Our safeguard compass unit communicates with us visually through the LEDs, and it communicates with us audibly through this alarm. Now, in the event that you may need to rapidly talk to somebody or you want to temporarily mute those notifications, you can do so very easily by pressing the center button sharply and quickly. That will put the compass unit in a temporary mute mode, and after an interval of 5 minutes, just to make sure that it doesn't stay in mute when we don't want it in mute, it will begin to produce those alarms again. Because the safeguard compass unit can be successfully deployed in so many different kinds of working environments, we added some very intentional adjustability to our voltage settings. When I want to change the voltage settings of my safeguard compass unit, I do so easily by pressing this center button down until I get these blue indication lights on the end. And when I see the LED illumination bar lit up with all 7 LEDs, I know this safeguard compass unit is set to the highest sensitivity, meaning it will give me alerts further away from a given voltage. And if I press this button again, I can drop it down to the very opposite of that. This is the lowest sensitivity range, which means I will be closer to a particular source of voltage. A good rule of thumb is the lower the voltage, the higher the sensitivity we want to operate the safeguard compass in. And when I find an appropriate level of sensitivity for my particular application, I simply press and hold this button down until I get those green confirmation lights, and then I press the button down again to select my appropriate level of current sensitivity, and now my compass unit is calibrated to that particular voltage sensitivity. It will retain that setting whether I turn it off or turn it on. The safeguard compass can be used in a myriad of environments. We've added current sensitivity adjustments to our safeguard compass, including the ability to completely ignore magnetic fields produced by current flow. If I want to change the current sensitivity of my safeguard compass, I merely hold the center button down until I get those blue lights. And when I get these red LEDs, that's my voltage sensitivity, I confirm that setting or adjust that setting as needed. When I press the button down again, I get those green confirmation lights. Now I've got these blue lights. Blue lights are our way of communicating current sensitivity. When this safeguard compass unit is turned on with all of the blue LEDs illuminated, that is when this device is operating in its highest sensitivity level, meaning it will give me a warning from a detectable magnetic field at a further distance than it would if I had it set here. In some working environments where there are very, very large magnetic fields, say for instance, places where there are a lot of generators or a lot of transformer windings, it may be well worthwhile to block your current indication. In this case, the compass unit will not alert if there is a detectable magnetic field. By pressing the button one more time, however, I can start to turn on or turn up its current sensitivity setting. Here is the lowest end of the spectrum, and as I press this button, I can literally determine the amount of sensitivity that is appropriate for that given work location. And when I find a current sensitivity setting that will work for that environment, I simply hold this center button down. I get those green confirmation lights. Now this compass unit is calibrated for the appropriate voltage sensitivity, the appropriate current sensitivity, and it will retain those even when I turn my compass unit off and on. With respect to electrical environments, there are times people have to work in the vicinity of two different types of fields, electric fields and magnetic fields. And at times, working in those locations means that we need a smart or intelligent device that is capable of discerning sudden changes. If I begin to approach an electrical conductor, the intensity of its electrical field will increase. So by using our smart adaptive mode, we can provide our customers with an ability to detect times when they start getting closer to an energized circuit that they may be aware of previously, but have temporarily forgotten about. The way I calibrate my compass unit to utilize that smart adaptive mode is like this. By pressing this center button down, when I get to these blue lights, I get to my red LED indication. This red LED indication right now indicates that this compass unit was previously calibrated to medium level of sensitivity. If I press this button a few more times, however, I can get to this indication. And at this indication, these lights strobing back and forth indicate to me that this compass unit can now be calibrated in smart adaptive mode. And when I want to select this mode, it's really easy. I press this center button down, I get those green confirmation lights. Now I'm into my current sensitivity settings. If I want to detect a sudden change in a magnetic field, say I wanted to become aware if we suddenly had a motor start up or suddenly had a transformer winding that became energized, I can calibrate my compass unit to that smart adaptive setting by choosing the mode where I see the blue lights strobing back and forth. If I press this button down and hold it, I get the green confirmation lights, and now my compass unit is set to the smart adaptive mode. One of the incredible things about the Safeguard Compass is a technology that no other personal voltage and current detector has right now. This technology is very powerful because it taps into a fundamental thing about voltage. Voltages produce electric fields, and electric fields, as they emanate from an energized conductor that has voltage on it, have a distribution that is sort of evocative of water spraying out of a broken sprinkler pipe. These electric field lines that travel a short distance are very strong. These electric field lines that travel a very long distance are weak. And that means with an intelligent device like this one and some brilliant engineering, we can place our compass unit in one of these electrical fields to determine where the voltage is. We call it directionality. So when my Safeguard compass is on, as I pass my compass unit back and forth through this electrical field, It looks for the weak lines and it looks for the strong lines, and on the basis of those lines, the onboard computer starts to tell us which direction the hazard is. The compass unit detects voltage and current because it utilizes the two fields that voltage and current produce. The higher the voltage, the stronger the electrical field. The larger the amount of current flowing in a conductor, the stronger the magnetic field. So the range of a compass is actually determined in some respects by the intensity of the field it is detecting. So if you have a circuit at a higher voltage, it will give you a warning or indication at a further distance away. If you are using your compass unit in vicinity of lower voltages, their electric fields will be correspondingly weaker, and that will mean your compass unit will give you an alert at a closer distance away from that particular circuit. Another thing is very important with respect to range. If an electrical conductor that is producing an electrical field because it has voltage on it is a long ways above the ground, those electric field lines can travel a great distance, meaning my range of the compass unit will be increased. And correspondingly, if the circuit that has voltage on it is very close to the ground, those electric field lines, as they come from that conductor that has voltage on it, want to couple with the earth, correspondingly, that electric field will be smaller. So range is determined not only by the voltage of the circuit that we're working around, it is also determined by where that conductor is or how high above the ground it is. And there's another thing that we need to be mindful of. Electric fields, as marvelous as they are, can be blocked by shielding. So if I've got an energized conductor within this panel here, this grounded metal enclosure blocks a large portion of that electrical field. With a safeguard compass, you've got a safety ally that is hands-free and communicative. It can communicate to this safety device called our ears and this safety device called our eyes. We do that through a couple of different colors and a couple of different audible alarms. When you see the red lights, that means voltage indication or electric field detection. When you see the blue lights, that means current detection or magnetic field detection. So if I hold this compass unit up to a circuit that has voltage and current on it, it will look at that electrical field and rapidly start to communicate to me where that point source is. And if you'll notice, our rhythmic chirping now is saying, aha, I see the electrical field and I can tell you where it is at its strongest. And correspondingly, if I take this compass unit near a conductor that has current flow on it, such as this neutral here, it will give me blue lights indicating that there's current flow. And as I move my compass unit in that environment, it will not provide directionality indications because that is impossible with a magnetic field. It will change in intensity as I move further and closer to it, but I will not get directionality or a change in the orientation of the lights and the noise of the alarm. Other lights that are important for the safeguard compass unit lights are green confirmation lights, white battery indication lights, such as this. If I want to check the battery status of my compass unit, when I press this button down, I get these white lights. When I see green lights on this LED bar pop up after seeing those white battery indication lights, and red on this side, that informs me that this compass unit is half charged. White lights are what we use to see how much our white lithium battery is charged. If I press this button down here and get to these blue lights, in the settings mode, those blue lights indicate that I can change my voltage and current settings. And when I select the setting I like, Those green lights are confirmation lights that tell me I have just selected that range or that sensitivity setting. And finally, if I press and hold this button down here, and I get to these green lights, that tells me my compass unit just powered down. Now, in the event that we have a low battery, we will see these two lights out here start to illuminate with a flashing red color. And in the event that the onboard calibration software detects some sort of irregularity or abnormality, the Safeguard Compass unit will give us a warning to that by giving us a green LED on this light bar and a red LED light on this end of the light bar that strobe intermittently that tell me, wait a minute, turn the unit off, turn it back on. There may be an issue with the compass. The Safeguard Compass unit is a marvelous piece of technology. It is a way for us to have a hands-free 360-degree circumferential device that is looking out for electrical hazards while I'm busy. It is not, however, a replacement for fall protection or observing minimum approach distances or wearing the appropriate and oftentimes necessary FR protective clothing. It is not intended to be used as a replacement for a hot stick mounted voltage detector or a low voltage multimeter or rotation meter or phasing set, etc. This is a piece of technology that we can bring into the cocktail of safety rules, knowledge, and various types of PPE to lift the safety of people working around electrical hazards.